So may 1 point agad kayo. So hindi na natin tatawagin na bago pa mag-survey tayo, tatawagin natin sila. So mag-GPS ba kayo? So hindi na ganun ang tawag. So ang pinaka-tawag na sa kanya ngayon, Genesis na. So parang dati di ba, pag pabili nga ng folding, tapos yung close up, red clicks. Di ba yun? So yun, Genesis na ang tawag, hindi na po GPS. So let's start yung so GNSS refers to a group of satellite systems that provide geolocation and time information anywhere on Earth. Tapos it allows devices to determine their precise location by receiving signals from multiple satellites. So ito yung sinasabi natin ngayon. So ito yung mga example ng GNSS natin. So meron GPS, ang may-ari niyan yung US. Tapos meron na rin yung Russia, GLONASS. Tapos meron ng Europe din, meron silang Galileo. Siyempre hindi papahuli ang ating best friend na China, meron din silang Beidou. Yan, so ito yung mga samples sa mga satellite system na meron na ngayon sa ibabaw natin.
Meron tayo, ano atin?
Hindi ko alam kung magkano na yun. Agila ba yun? Tama ba? Ayun, basta meron tayo nilaunch before. And so nag-start siya nung nilaunch yung Sputnik 1 ng Russia nung nag-start yung Cold War noong 1957. Tapos, naglabas din yung US ng transit system developed by US Navy. So, papansin nyo, yung GPS, GNSS na ginagamit natin, nag-start sila dahil sa gera before. So, 1957 yung Cold War, tapos sumunod yung sa Vietnam War. So, ito yung so before nag-start yung Russia nung Sputnik nila, tapos later on naglabas na rin yung US, tapos meron na rin yung Russia, nag-GLONASS, tapos yan ang Europe nung year 2000, tapos after nun, yung China na rin, so dapat meron din daw sila. Kasi may sarili silang mapa na ginagamit. Yan, short lang actually ito para mga 100 slides na. So, how does GNSS work daw? So, satellite orbits Earth and continuously sends signals. So, kailangan meron kang nagsisend ng signal doon sa taas, sa ibabaw ng Earth, tapos dapat meron tayong receiver na ginagamit. So, ito na yung mga RTK natin, yung mga device na, yung mga phones actually, meron na ngayon. So, before, walang gano'n, gumagamit pa talaga sila ng mga devices para makagather ng So, the receiver calculates its position by measuring the time it takes for signal to reach from each satellite. So, meron silang computation na distance, range, or range equal to time times velocity of light. So, medyo technical yung yung formula niya, pero later on sa slides, papakita natin. Mas maintindihan nyo yung ginagamit na formula nila. So, this position is displayed as latitude, longitude, and altitude or elevation do sa map. Ayan. So, i-play ko to para mas maintindihan nyo. Ay, sorry. Ay.
Click nyo na.
Ito pala dapat.
Yeah.
So, ayan. Hindi po premium ang account ko sa YouTube. Ay, wala saan? Spaghetti ba merienda?
Merienda na agad.
Oh, sorry.
Ay, hindi. Baka walang sounds yung commercial.
Oo, naka-copy mo naman. Or wait. Oo, naka-copy. Kaso naman wala yung mouse. Pag-ihanap ko yung mouse.
Isa. Yan. Yan. Yun.
Connect naman ako Big.
Ano yung chocolate?
Pag malakas ang gutom, tuloy ang galaw. Pagkain araw-araw.
Tatlo yan.
Insert skip address.
Your
Yan.
phone can pinpoint
Okay.
your exact location thanks to to the Global Positioning System or GPS. But how does this technology work? Behind the scenes is some simple math. Let's dive right into it. To tell any location, we often use reference points, like saying that a cafe is near a grocery store or opposite the park. But these can be subjective, vague, and imprecise. So what's a better way to share any location without relying on such reference points? To answer that, let's simplify things by imagining a 2D world and use this flag as a fixed reference point. If I tell you that I am at 10 meters from the red flag, could you locate me? I could be 10 meters in this direction or here, in fact, anywhere on this circle. So just knowing that I am 10 meters from this flag is not enough. Let's bring in another flag. If I also tell you that I am 20 meters away from the blue flag, is this enough to locate me now? Being 20 meters from the blue flag gives another circle of possible locations. But to be 10 meters away from the red flag as well as 20 meters from the blue one, I could only be at either of these spots. Down from many possibilities to just two, but still not precise. To pinpoint my exact location, we will need a third flag. Say I tell you that I'm 30 meters from this green flag, we get another circle of possibilities. But the only point that is 10 meters from the red flag, 20 meters from the blue flag, and 30 meters from the green flag is this, where the three circles intersect. That's my exact location. No other point can be 10, 20, and 30 meters away from these three flags respectively. By the way, we call this set of numbers or distances 10, 20, 30 as my coordinates. Every other point on this 2D world will have a unique set of coordinates. Like this point has the coordinates 25, 30, 10, and the point with coordinates 15, 25, 20 must be this one. So if we have three reference points and I give you a set of three numbers which tell my distance from each point, you can always locate me in this 2D world. What about our real 3D world? In this case, the reference points are the satellites circling the Earth. Your smartphone communicates with some of these satellites and calculates its distances from them. How? Satellites send signals with timestamps, which are accurate up to a billionth of a second thanks to the atomic clocks they use. GPS receivers in your phone pick up these signals and look at the difference between the send and receive times. By multiplying this time with the speed of light, we get the distance between your phone and the satellite. So how many satellites do we need to know your exact location? Say we have just one satellite and your phone knows that you are 12,000 miles away from it. Is that enough to locate you on Earth? There are many points that are 12,000 miles from the satellite, forming a sphere, and you could be anywhere on this sphere. So, one satellite is not enough. Suppose we add another satellite, and your phone detects that it is 13,000 miles away. Now you could be anywhere on the surface of this sphere. Considering both distances, you can be anywhere on this circle, formed by the intersection of these two spheres. We are down from a sphere of possibilities to a circle, but still not enough. Let's bring in a third satellite. If you are, say, 14,000 miles away from it, we get another sphere of possible locations. This sphere intersects the previous circle at two different points. So given the three distances, you could be at either one of these two locations. But which one? For that, we need a fourth satellite. If we know the distance from this one as well, say 12,500 miles, we get a fourth sphere. It intersects the previous three at a single point, and that's your exact location. So, to locate anything precisely on Earth, we require distances from four different satellites, which gives four spheres intersecting at a single point. And that is the simple math behind GPS, enabling us to accurately track everything from packages to airplanes.